All right, today we're going to look at the last section of Chapter 7, solving radical equations and inequalities with radicals. This first one is an example of a problem that has radicals in it. It says computer chips are made from the element silicon, which is found in sand. Suppose a company that manufactures computer chips uses the formula, and you can see the formula on your sheet, to estimate the cost in dollars of producing N chips. What would it cost to produce 27,000 chips? All right, so we got to figure out where are we going to put that 27,000. It's talking about chips. Looks like N is chips, so we want to put that in for N. So substituting that in now, we got 10 times 27,000 to the 1/3 power plus 1,500. All right, we want to solve that. We got to start with exponents. Order of operations says start with exponents. So we want to simplify that part first. Remember, from last week, if you have something to the 1/3 power, that's the same as the cubed root of 27,000. So on your calculator, calculate that out. You can either do it as a cubed root or to the 1/3 power. Either one should work. Let's check it out just to make sure. So on the calculator, you could either do 27,000 to the power of 1/3, which equals 30, or to the cubed root of 27,000. You also get 30. Either way, you should get 30. So now we know we got 10 times 30 plus 1,500. 10 times 30 is 300. Add that to 1,500. Looks like the cost would be $1,800. So that's a type of word problem where you need radicals to solve. Let's look at another one. Now, in these next problems, we want to solve radical equations. We're trying to solve where there's some kind of root or fractional exponent inside the problem. So we got to figure out a way to go through and still solve that, as in number 1. So in order to solve that, what we need to do is try to get that radical part by itself. Try to get this part by itself, which means we need to get that 2 out of there. How do we get the 2 out of there? Subtract it. Subtract 2. If we subtract 2, what we end up with is square root x plus 1 equals 2. Now our job, get rid of that radical. How do we get that radical gone from our problem? In this case, square root, we recall from before, what's the inverse of square root? Squaring, power of 2. So if we do it to one side, we have to do it to both sides. If we square both sides, the left side, square root and power of 2 cancel. We got x plus 1. On the other side, 2 squared is 4. Now this is easy to solve. Subtract 1. Our answer is 3. Now, does our answer work? When you're doing these, you should check your answers, because with these root problems, even though you solved it right, sometimes your answer doesn't make sense. Once in a while, we get what's called a extraneous solution. So sometimes you'll be able to obtain a number that doesn't satisfy the original equation. This is called the extraneous solution. If this happens where you plug it back in and it doesn't end up working out, then we write no solution for the answer. Let's see if this one actually works. So plugging back in, do we get 4? Well, if we plug 3 back in for x, we got square root 3 plus 1 added to 2 should equal 4. That's square root of 4. Simplifying square root of 4, we get 2. 2 plus 2 does equal 4. This one does check out. This answer is a good one. So the answer to number 1, x equals 3. All right, we got that one. Piece of cake, right? Let's try another one here. Problem 2. We want to solve this one. A little bit different problem, because we can't, on this one, we can't just isolate the radical, because there's one on both sides. So in this problem, again, just to get rid of square root, we're going to have to square. Square both sides. If we square the left side, it makes it really nice. X minus 15. On the right side, we got the quantity 3 minus square root of x squared, which means we have 2 of them. We're going to have to go through distribute using that FOIL process to see what we get. So going through and doing that, let's see, we got 3 times 3, that'd be 9. 3 minus 3 square roots of x minus another 3 square roots of x. And then we get negative x times negative square root of x times negative square root of x. 2 negatives makes a positive. Square root of x times square root of x would be x. All right, we got to keep simplifying here. Let's see, we can combine those two terms with square root of x. That'd be minus 6 square roots of x. What else can we simplify? Well, notice there's an x term on both sides. We should be able to cancel those out. Anytime we got one on each side, we could subtract that. Both of them are gone. All right, now what can we do? Well, let's get our numbers together. Let's subtract 9 from both sides. And if we subtract 9, now we got negative 24 equals negative 6 square roots of x. Well, let's divide by negative 6. Dividing by negative 6, that's going to get us closer to the answer because now we have a value of 4 equals square root of x. All right, how do we undo a square root? We did it already. Square both sides. And it looks like we get an answer of 16. Now again, check your answer. We need to go back and check. Does 16 actually work if we put it back in the original problem? Let's find out. If we put that back in the original problem, so putting 16 back in the original problem, we got square root of 16 minus 15 on one side. The other side, we got 3 minus square root of 16. 16 minus 15, that's 1. Square root of 1 is 1. On the other side, square root of 16 is 4. 3 minus 4 is negative 1. Did both sides come out to be equal? No. So what is the answer for number 2? No solution. That's an example of a problem with a extraneous solution. That has no number. There's no number for x we can put in that makes it both sides equal. No solution for number 2. All right. Let's take a look at number 3. Let's try one more together here. Trying this one out. Looks like we need to add 1 to both sides. So go through, add 1, see what we get. Looks like that one equals 6. Why don't you keep solving, see if you can get the answer from here. Why don't you pause it and see what you get from that one on. So keep going, see what you get. All right, let's see what you got. We already added 1 to make 6. Opposite of square root is to square both sides. We want to square both sides here. What do we get if we square both sides? Well, on the left side, we just got x minus 2. On the other side, 6 squared is 36. Add 2, you get 38. Did you check it? Put it back in. If you did check it, you should have said, yes, that one does work. That one checks out. All right, those ones all had roots. Now let's look at some with fractional exponents, as in number 4. Number 4, no more radicals, fractional exponent. But we know fractional exponents are the same as radicals, so we want to solve in a similar way. Just like with the radical problems, our goal, get this part by itself. How do we get by itself? Well, we're going to start out, add 2. Next up, we got to get rid of that 3. Let's divide by 3. All right, now we get to this step. We got it equal to 2/3. Now, how do we get rid of that power of 1 over 3? Remember, that's the same as the cubed root. So to undo it, we want to multiply by the reciprocal of 1 over 3, which is 3 over 1, or just 3. So both sides we want to take to the 3rd power. 3 times 1/3 is 1. That cancels out. So on the left side, we got 5n minus 1. On the other side, we got 2/3 to the 3rd power. Remember when you got a fraction to a power, you square the top, or cube the top number and cube the bottom number. So If we simplify that out, that's 27, or I'm sorry, 2 to the third power is 8 over 27. All right, we got to keep going. Looks like we need to add 1 now. We need to add 1 to 8 over 27. That's probably where we want to use calculator again, so let's see what we get. If we add 1 to 8 over 27, 8 over 27 plus 1, you get this number. To get as a fraction, hit math. Fraction, looks like it's 35 over 27. All right, now we need to divide by 5. So divide both sides by 5. We could also multiply by the reciprocal. If we multiply by the reciprocal of 1 over 5, that cancels out. We get n equals. On this other side, we got this term 5. We can see how many times does 5 go into 35. 5 goes into 5 once, goes into 35 7 times, so we get an answer of 7 over 27. If you plug it back in, it does check out. So the answer is 7 over 27. All right, let's look at another one here. Number 5, we want to solve this one. Again, it has a fractional exponent. We'll go through same similar way though. Start by adding 2. Okay, how do we undo something to the 1/4 power? Take it to the 4th power. Reciprocal power is 4. So on the left side, we got 2y plus 6. On the right side, 2 to the 4th power is 16. Now it's a simple algebra problem. We can finish solving this. Subtract 6, divide by 2. The answer is 5. And this one, plugging it in, does check out. Why don't you guys try number 6? Pause it, try it out, see what you get, and then check your answer. All right, let's see what you got. Subtract 5. This one, you want to take both sides to the 3rd power. So cubing both sides, we end up with 3y plus 1 on the left. Negative 5 to the 3rd power should be negative 125. Subtract 1. Get negative 126. Divide by 3. Should have got an answer of negative 42. And it does check out if you plug it back in.